Hello, everyone. We will be getting started shortly. There's still a few people that are coming in. How's everyone doing? Just let me know in the chat. And again, if you haven't already, make sure to check in at the link. Good, good. Make sure to check in at the link that I've provided, just so that we can get a head count of about how many people are here. Good evening if you are in the Western Hemisphere. I'm doing well. How's everyone in chat doing? That's good. That's good. I'll give you all a few more seconds to just make sure you check in. And in the meantime, I will let you all know what we're going to be doing today. So today we're just going to be doing a fairly simple Python program. It's going to be largely just the data analysis and data visualization. So for that, we will be using Python. It's very beginner friendly. So if you have no experience or very little experience in coding, that shouldn't be an issue. You should be perfectly fine. And if you have any questions at all, just put them in the chat. I'll be reading it regularly. And if someone who is in the chat knows the answer to a question, feel free to answer. And that should be it. All right. The check-in link is taking you to Twitch. It should not. So we have one link that's also in the Discord. If the link that I put in the chat over here does not work, you can head over to the Discord. It should be under GHW-announcements. You should be able to find the link over there. All right. Okay, easy afternoon in the West. Yes, I'm currently in Texas and it is very, very hot. So we're enjoying that weather. Okay, let's get started then. Hopefully you all can see my screen. So again, it's going to be Python program. It's going to just be earthquake data visualization. So real quick, let me just show you all what we will be making, and then we can get into sort of how to make it. I think it gives it, being able to see what you're making, it gives you a good idea of sort of the structure or what you should do to create this. So real quick, let me just pull that up. And here it is. It's opening a few more tabs than it should be. Okay, so over here, if you all can see that, this is essentially what we will be creating, right? So over here is sort of a visualizer, and you have a map of the entire world. You have a little visualizer right here, like a timeline almost, where you can sort of scroll through the different days and see what earthquakes happened on what day. So it's pretty cool. And then on the right side, you have a sort of magnitude meter, which ranges from over here, it's 1 or 0 magnitude all the way to 6. So you can sort of visualize that over here. Again, you can, if you want to later on, you can also customize the colors for this. You can change the sort of map that's being displayed. There's a whole lot that you can do, and it's all running locally as well. So it should be pretty simple to get set up. Okay, any questions before we get started? Just let me know. Shake it, Cali. Yes, it is in the Ring of Fire. You can sort of see that that circle or that ring of just where all the plates mesh together. And yeah, you can see there's a lot of smaller earthquakes that happen over here. A whole lot of them, about like, so if you add a sort of filter for the minimum magnitude, which we will also be doing, then you can see that there's actually a lot fewer earthquakes that happen in Cali than you might think. So you can see all of these are like light blue to dark blue, which is very low. It's in like the below 3 range, versus over here in the east where it's on the higher end of 4.9, 4.2. Okay, so that's a little intro on what we're going to be doing. You all ready to get started? All right, so we do have one question. Click join event, it opens in Twitch. Okay, it's good you got that figured out. Anyone else having issues with check-in, you can just let me know after the fact and we can work on that offline. All right, so let's get started. First things first, we sort of just want to outline what we're going to be doing and how we want to go about doing it. So usually the way this works is you all have seen how sort of the project is going to look. So in terms of the data source, right, because that's probably the most important thing, where you're getting your data from, we are going to be pulling it from, I believe it's called the USGS earthquake website. So that's sort of where the US government is collecting all the geological information. And that's what we are going to be using as our data source. So USGS website, and you all can search that up online, or I can drop a link in the chat as well. Let me grab you all a link to that. You can have VS Code, you can have PyCharm up for this. Not a huge deal what you use, as long as it is a Python file. It can be in a Jupyter notebook, that's perfectly fine, or you can do it in a just in a regular .py environment. That also works because it opens it up in a separate web browser anyways, and then it opens up a port for it. So it'll be almost like a web page that's being run off of it. So a normal Python file should be fine. You'll have no issues when using that. Okay, so we know our source is the USGS website. I've sent you all the link to that, so that should be pretty straightforward. You can take a look at the documentation real quick if that is helpful to you. Just get a quick overview, a quick outline of how everything looks. So that's where we're getting our data from. At a high level, what we're going to be doing is essentially just all the data cleaning and all the logic, clean up the data, figure out what we want to do with the data, figure out what each column in sort of the data is, and sort of work with that as a data frame in Python, which is just a table. And we'll just be doing analysis on a select few number of columns. All right. So that is about it. Any questions so far on any of that? Okay, if not, then we can go ahead and get started. So in our Python environment, obviously, we want to, first and foremost, import all of our dependencies. So for this, we will be using pandas. So import pandas as PD. And we also are going to be using Plotly for the graphs. So all those charts, the graphs, the maps that you saw in the web browser, those were all done using Plotly. So we're going to import plotly.graph objects. And then, because it's very long, we will shorten that to geo, and then import express as px. Okay, so these are actually all the dependencies that we really need. If you get an error that says plotly is not installed, then just you can always pip install plotly in your command line, and that should give you full access to everything that plotly has to offer. Okay, so first and foremost, what we need to do is actually fetch all the earthquake data from the USGS earthquake API, correct? So for this, we can go on their website, And we can actually just take a look at the data real quick if we want to. So let me pull that up for you all. So the data source over here would be this right here, and summary over here. You sort of have to put a date or time range, right? So you can either do a day, a month, or a week. So let's say we wanted to do all month. And then if we open this up in our browser, we will get a CSV file, which has all the data on there. And that can be very easily converted to a Python data frame. So you can see right here, this is the CSV that was generated if we open that up in our web browser. Okay, so you all can feel free to go ahead and put that in your web browser, and you get all of this information. So this right here is a lot of info. We don't need to use all of it. There's only a few columns that we're really interested in. So the first one is because we're making a timeline, obviously the time column. So this is something that we would need to keep in mind. I definitely can share the link. Let me get you all that. So this is for a month. If you want to get one for just the day or just the week, just replace the word month with day or week, and you'll be able to access the CSV file of that. All right. So again, we have the timestamps that are over here, latitude and longitude, which is also very important. We will be using these columns as well to um, plot the earthquake locations. We also want to look at the magnitude of each of the earthquakes, so how powerful each earthquake really was. We're not too interested in all of this information. There's some missing info, and we don't really want to work with that. So, and it's not too important for what we're doing, so we can ignore all that from now. Same thing with RMS, net ID, updated. Place is an interesting one, so we will most likely be using place because this can tell us the approximate location of the earthquake, sort of in a way that we know it. So this one right here says, okay, this is 5 kilometers west southwest of Point McKenzie in Alaska. So we know that this is in Alaska. This earthquake happened in Alaska, and you can do that for the rest of the column as well. So we will be using this column as well. This column O is just the type. So again, the USGS website collects more than just earthquake data. I think it collects data for all natural disasters. So this one we won't be using because we know everything we're using is for earthquakes. And then everything else we can also just ignore because we will not be using that. All right, so that's sort of just a high level look at what this data is. We will be pulling it directly from the source when we are writing in our code. So you can download it if you want to just take a look at the data, take a look at the structure, but it's not necessary for when we are running the program. All right. Any questions so far? I will give it a minute just in case anyone has anything that they want to say, and you all can take a look at the data as well in the meantime and sort of just explore the way the CSV file is set up, and then we can get started on the next part, which is actually writing the code. Okay. So for the most part, it is the question that was asked was, it's just data visualization, or are we going to manipulate and infer from the data, right? So it is largely data visualization. Manipulation of data, we are sort of doing, we're not actually changing any of the data, but we are going to be using this data and selecting which one of the columns we want. So that could be interesting. And we can obviously just infer location and things of that sort from the data, which is already given to us. Yes, there's quite a bit of data, so we will have to do a little bit of filtering it as well. A little new to Python. Okay, the question was we have to write a data source command for using the CSV file in Python. Yes, we will need to know what the source of the data is for the Python program to know where to pull the information from. So we do need to type this out, or not this specifically. We'll get to it because we want to be able to select if we're doing the full month, we're doing a week, or we're doing a day. So over here, I was thinking we can abstract this right here, right? And then this will be whatever we want it to be between the two brackets. So we can change that however we'd like. All right. Good questions. Any other questions? Okay. So someone asked that they have an could not be resolved error. Again, just pip install whatever you're importing. So if you're trying to import pandas, you can just type in pip install pandas, and that should install pandas for you in your command line. So you can see I just typed that out. I already have pandas installed, so it says it's satisfied. Yep, that is exactly it. Okay, so now to get into the actual code, there's really two main parts to the code over here. So again, the first one is just to sort of fetch the data and write all the like helper functions to clean it up, fetch data and clean it. And then the second major part is just creating the visualizer. So create visualizer. All right. So first and foremost, let's start with fetching the data and cleaning it up. So first and foremost, we want to figure out what sort of period we're going to be using the data. So are we doing it for a full month? Are we doing it for a week? Are we doing it for a day? And based on that, we're going to be changing sort of what the visual looks like. And also we need to know what region. We're usually just going to use the worldwide region, but if you want to, you can also dig into it deeper and specify a specific region where you are where you want to see earthquakes from. So for instance, if you only want to see earthquakes in California, you could specify a region as California and then use that alone. And we can also apply a magnitude threshold. So what's the minimum threshold that we want the magnitude to be so that we only see earthquakes that are over this threshold, right? So with that, let's get started. Aditya asked if we can do this in Google Colab. You should be able to run it in Google Colab. That should not be a problem. It would be very similar to doing it in Jupyter Notebooks. All right, so first things first, what we want to do is actually fetch the earthquake data, right? So we can create our first function, fetch EQ data. And over here, like I said, we want to have three parameters, and that would be the period, the region, and the minimum threshold. So period is, let's go with daily. We have a region, which we're going to set to worldwide. And we have a magnitude threshold, which we're going to set to, let's go with min mag. That's just minimum magnitude, which let's set this to 2 or 1 so that we're not seeing anything that's less than 1. Okay, then of course we need to actually define where we're getting the data from, right? Where we are getting data from. And this will be the URL over here. So we can just copy and paste this data source. So let's call this URL equals this. And let's clean it up. There we go. So this right here is what our URL is looking like. All right, so now that we have the URL, which is where we're actually getting the earthquake data from, next we can actually select, we want to adjust this period or be able to adjust what this period is, right here between the two brackets. So we can change it based on this period right here. So again, this is the default period. We can always change that later on. So if the period is weekly, then we want to format the URL to say all week within these brackets, right? And same thing for monthly, same thing for daily. So we can start with if the period is weekly, then we are going to change the URL and let's make this a new URL equals this earlier URL that we used dot format, and we're going to format it so that in between the brackets we have all week. Okay, and then we can do the same thing for monthly and daily. So else if the period is monthly, then the new URL can be formatted to all month. Thank you for that call out. Okay. URL format all month. And lastly, otherwise, we are going to set the new URL to all day dot format all day. Okay, so what this should do is it's just figuring out which one of these do you want to be fetching, right? Are you fetching a weekly period, a monthly period, or just a daily? We can do yearly, but that's going to be a huge amount of data. So I decided to forego a yearly amount of data because that'll be very heavy on the application. Although if you do have a more powerful device, you can go ahead and experiment with that for sure. But if your computer crashes, that is not my fault. Okay, so we have all this information, right? This is just setting it apart by period. Next, we want to actually fetch all the data and extract all the columns that are going to be relevant, right? Fetch data and extract relevant columns. So for this, we need to use the read CSV function, and we're probably going to make a data frame for this. df earthquake. This is a very long variable name, but I'm doing this for the sake of readability. Is going to be pandas.readCSV, and we are passing the new URL. All right, and then after that we have this, now this is the entire sort of CSV that's stored in this data frame. If you're using Google Colab or then you can sort of see what the data frame currently looks like. So what we want to do now is we want to clean it up and only use the columns that we were looking for. So if we go back to, where's this? This right here, our CSV file, we know that the ones that we want are time, latitude, longitude, place, and I feel like I'm missing one. Magnitude, yes. So magnitude is mag, we just need to keep that in mind. And everything is lowercase. All right. So now we can just sort of cut this down and set df earthquake to df earthquake. And we want to only select the time, latitude. Is it shorthand or is it fully, it says, okay, latitude, not lat. Latitude, longitude, we want the mag and place. Okay, so this should now only return a data frame with these 5 columns. All right, so now that we have all the earthquake data, we've extracted all the relevant columns. Next, we want to actually be able to extract sort of sub-area information from the place, right? So the place is formatted in a way that gives you the sort of how far it is from the nearest, how far in which direction from the nearest city and state, right? And I believe country as well. Okay, yeah. So of this city in this country. So for US, it uses states, and for everywhere else, I think it uses countries. So what we want to do is we can split this up by the comma and use this information to sort of be able to identify where everything is. All right. So let's do that next. And this will just be extracting sort of the, we can call it the sub area in place, in the place column. All right, so we have the place list, and that would be the column for column in DF earthquakes. That's called place. And we want to split this by commas. So dot string str, I believe, dot split, and then we are separating it by a comma. Okay, and then we want to actually, we can add another column to this DF earthquake data frame, and this will be called sort of sub area and area. So we're just going to split this into 2 separate columns. One of them is going to be called area, one of them is going to be called sub area, and then we can just drop the place one altogether. So now we have it in sort of a cleaner format where this, instead of all being in one column, is going to be split into 2 columns. One is just going to be how far it is from this location, and one is going to be the location itself. I did not mean to make that full screen. Okay. The space after the comma, it is not needed, but it is probably better to have, because I saw there was some special characters in here. But if you look at all of these, you can see that there is a space and then a comma after every location or in between all of these. So it's better to have just in case there is a like spare comma somewhere here. Trying to find where the Japanese one was. Right here. So you can see there's some like strange special characters in between. So it's better that you use separator as a comma space instead of just comma, just in case you have an issue with that. All right, good question. So we have a place list, and then we want to sort of add a new column to this data frame. So we can call that sub area, and this will be the place list, and then we can apply the sub area extraction. And for that, we will probably need to make another function. Apply, and then some function. So we will get back to this. All right, so we can actually create that function right now. What we want to do for that is just get the first value in that index, because now it's split into an array. So we can actually just define this as extract sub area, and this will have place. And over here, we just want to return place at index 0. Okay, that should be it for sub area. And then we can also, while we're here, we can also do that for the area itself, and that'll be the first one. So for that, we can do def extract area. And for this, we want to return, we can either return place 1, which would be the second item in the list, but we are not 100% sure if that is the second item or not, because we're not 100% sure about how the data is formatted. So a safer bet would actually be to use a negative index, and that'll sort of reset. So it'll go back and wrap around to the last indexed value, and that is probably the safer bet. So you can return place -1 instead of place 1, and that should get you the last index instead of the second index. All right. So now that we have that, so we've got one comment that says some of the rows have only a state, not an offset. That is true. So for those, we will be able to take care of those as well with this. So not having an offset is not an issue. It'll just be an empty value in the column. So now that we have our sub area, we can extract the sub area from this. Okay, so we're just applying this extract sub area to the entire data frame, and then we can do the same exact thing with the area. So we can df earthquake, and this will just be area. All right, as we place list dot apply, and this would be extract area alone. Okay, so now that we have both of these, we can drop the place column entirely. So df earthquakes is the same thing, only this time we are dropping the columns with the name place. Okay. This equals 1 just to be safe. All right. So this right here should extract the sub area, and now it's dropped the place column for columns with the name area and sub area instead. All right. Next, what we want to do is probably filter the data based on the magnitude, right? So if you want to define a threshold for the magnitude, we're like, okay, we want a maximum of, or we want a minimum of, let's say, magnitude of 1. So we can actually filter it out based off of that. So let's write the functions for those. This would be filter data based on min threshold. So the question we got was, what does dot apply do? Dot apply applies this function to this entire column. So the entire place list will have this function applied to it. The extract area function applied to it, which we can see over here, is just returning the last value in this array. All right. So next we want to do is filter the data based on the threshold for the magnitude of this. So for this, we can write our conditional statement. So I want to know if something is an instance of something else. So we can honestly just use if is instance and magnitude threshold. What did we call this? Min-mag. Integer, and the threshold is greater than 0, then we want to set df earthquakes to anything that is above the threshold. Open df earthquake magnitude is greater than or equal to the threshold. Okay. Otherwise, it's just anything that is greater than 0. This shouldn't be necessary, but likely good to have. It just checks if that is an instance of something. So if min-mag is an integer, then we can do this. So we can actually is int or is instance and as like a float. So you can also do it with floating point numbers as well, or we can just leave it as an integer. I'm going to leave it as an integer right now so that we can play around with it, but we can definitely come back to that and change it to a floating point number, just so that we know, just so that we can adjust the range based off of a double or a floating point number. So this will filter the data based off of the magnitude threshold that we set for that. Then let's see. Once this is done, we can either start working on the visualizer or we can start working on the actual time columns. So let's work on the time columns first, just so that we can clean up all the data at the same time, and then we can work on anything visually based. So this is pretty quick. This one, we just want to change it to the pandas. I think their preferred format is a datetime format. So we can just convert to, what is convert time to PD date time. Okay. And this would be df earthquake at time is equal to the pandas dot to date time and this would be the time. DF earthquake at time. There we go. I believe that is correct. 2-day time. Okay, that is. So this will convert just the time column in, I think it's in Zulu format right now. That was converted to the pandas date time. All right. So we have that completed. Next, we just want to work on, we can start working on like the actual visualizer, but for that, we need to do a little bit more cleaning with the data. So we'll get to that. But before I move on, I think it's a good time to take a little break and ask if there's any questions so far. So someone asked, don't we need to drop the place column? We did that on line 34. So this right here is just setting the DF earthquake to the same thing, only with a dropped column. So this is changing the data frame. Any other questions? Extract area is a function somewhere. Let me actually push all of this to a GitHub repo so that everyone has access to it. And then if someone else joins later on, or if someone wants to review the code, I think that'll be a great place to go. So let me actually do that right now. But you can see the extract sub area and extract area are two functions that we've just defined over here. What should we call this? It's part 1. Okay, let me send you all the link to that GitHub repo, just so everyone has that. It would be over here. Okay, so just sent the GitHub link. If anyone is behind or wants to double check any of their work, that is the source. That is the truth, source of truth. I think that's the word. So just check it out over there. And if you have any questions, again, feel free to put them in the chat. You are welcome. Okay. So we've gotten all of this done. We've done a lot of probably what the first part is, which was just fetching all the data, cleaning all the data. Next, what we want to do is sort of fix the latitude and longitude. We haven't touched those two columns yet. So for those, we just want to set sort of a default value if we don't know what the region is. All right, so let's work on that next. That's not how you spell set. If not found, okay. So for this one is if the region in the data frame is to list, I believe. Then we want to set the data frame to its region. Okay, so that would be DF earthquakes equals itself, and then we're setting the area to the region. 1 second, this is DF earthquake, and then we are resetting that to data frame of earthquakes, and in that the area to the region. So this is just making sure that we have a region for each sort of value in the data frame. Okay, then we have like a maximum magnitude as well, which we can also be checking out. So that would just be max mag, which is the maximum of all the magnitudes. So this would be df earthquake magnitude dot max, and that'll sort of set it to there. Then we want to set the center latitude and the center longitude otherwise, so that would be center latitude. This would just be if the magnitude is the max magnitude, then we're going to be setting it to that. Otherwise, it is defaulted to the center. Okay, so df earthquakes, df earthquake, and this would be the magnitude equals the max magnitude at longitude value, or this is latitude value, latitude 0. And then we do the same thing for the longitude as well. So we can honestly just copy and paste this, and all we would need to change is this value right here. So this is just setting the center to whatever the highest magnitude earthquake was in the region. If that is not, or if it's not able to find anything, then we can just set it to anything. Is a center lat, comma, center long. That is this right here. And we can just set that to any arbitrary value. I have, when I was working with it earlier, 54 and 15 worked the best as sort of the center of the map. So it's just setting the center if it's not able to find a region. Okay, that was kind of long. Any questions? We do have a question. Want to be less than 0? Else, where is it? DF earthquake. Samaha, I'm not sure if I follow what you're talking about there. Okay, we're just gonna give you all a second to catch up. If you have any other questions, throw them in. Okay. That is downtown Manhattan. Is it? Will center lat have values of 0? Yeah, no. Okay. Now that we've gotten the latitude and longitude taken care of, the last one is just to create, because we want to create sort of animation frames, right? We're trying to create frames for animation, and that'll be split based off of some value that we specify. So depending on what we're looking for, we want to create sort of different frames or different frame lengths, right? And we want to do that for either weekdays, hours, or the days in a month. So, okay, someone's asking to see pictures of certain lines. Let me just push this to the GitHub. And again, you can just take a look at the GitHub and everything should be on there. You are welcome. If I ever forget to do anything, feel free to remind me in the chat. I have that open and I'm looking at it. Okay. So again, next we want to sort of set the columns for animation frames, right? So set calls for animation frames. So this will be in the DF earthquakes data frame. We're just going to add another column, and this is sort of just going to be the frames for the different animations. So you might have remembered when I was showing the animation, I hit the play button, and it was almost like a slideshow where it showed one picture of the map, and then it sort of shifted. It kept showing different pictures. So that's essentially what we're doing over here. We're showing different snapshots based on whatever values we provide. Okay. So for this, we want to do it by period, right? So if the period is weekly, then we want to set the name frame call to, we can do a day of the week, weekday, set it to weekday. And set DF earthquakes at this animation frame column, which is weekday to DF earthquake. And this will be time. And we're going to be applying some function over here as well to just extract what the day of the week is. So to be continued. And then we need to do that for every day in the week, right? So this will be for, I guess, weekdays. It's not. For weekdays, we need it for dates, and we need it for hours, depending on what we're doing. Okay, so we can go ahead and create those sort of helper functions now, and those will just be to sort of extract the time out of the column with the date in it, right? So let's work on those next. And let me push this actually. So if anyone needs it, they have it. And push. Okay. Oh, did I not save it? I did not save it. Git add commit. And let's push that. Okay, there we go. Okay, next what we want to do is extract sort of the time from the data frame, right? So we can do extract date, and this would be from the time string that we're going to be feeding it in from the data frame itself, right? So extract time, and from this we will just be returning the actual string with time, and we're just going to be splitting that by, let's check it out. Okay, so it's in this format right here. And we can return it as a string of time string, and this will be split using a space character for the very first value in that index. So this is just extracting the date itself. And then we can do the same thing for the weekday, and we can do the same thing for each hour. Okay, so extract, I guess, a day of the week. Day of week isn't, we just write weekday, although weekends are also fine. So given the time, what we want is the time and day. So we can use actually this previous function that we made and just reuse that. So date is time, or let's see, extract date. And we are extracting the date from the time string, right? And then we can use the date when we are returning this. Right, so this would be return the date, and then we can add a delimiter. Let's clean it up a little bit, and then stringify. String dot, or not dot, string time dot week day. Okay. I believe that is correct. And again, this is because of the we changed everything to a pandas date time, and they have a bunch of built-in functions which make all of this significantly easier, which is why we are doing all of this. So again, if you take a look at it with the date time, you look at it with the date time conversion, you can see that it's sort of changed the Zulu time into date time, and it's much easier to work with. So over here you can see it's like we're just extracting the weekdays from it, and so on and so forth. All right, and then we can do the same exact thing for just hours. Okay, so we can write our last function. Hopefully this is our last helper function. This is just extract hour. Extract hour, and from time. And in this, we are just going to times are used. T is stringify the time string. And this one you want to split by space again. And then you're just going to return this time string. And because we want to maintain the same formatting as before, T0, this is the next one in this time string, or this T1, and we can split that by the time separator, and we're going to be using the hour, so that would be the very first one. Forgot a plus there. Okay, these are all the helper functions. Let's actually add this as well. So just push that so you'll have that ready to go. Okay, so that's it for all of the helper functions, hopefully. We'll get back to that, and let's see any questions that you all had. GitHub repo link. Okay, thank you for sharing that. Did not understand the area code or the lat long code. What specifically didn't you understand? Aditya. And then Maruti said, I guess we can access weekday and those values using Panda's datetime module. That's right. Yeah, they do have the inbuilt functions, and that's what we're using over here. So we're just using their inbuilt functions because if you remember, we actually converted everything to Panda's datetime, and that was able to this basically makes working with all time much easier. The region and the center lat part. So this right here is pretty abstract. This one just is saying set it to some location. But over here, it's just setting it to a default, right? So it's defaulting to the area in which the highest earthquake happened. That's going to be the center of your screen. That's all it's doing here. And then if you want a more detailed explanation, you can hang around later and we can go over it in more detail after this. All right. Okay. Let's continue. So we were over here where we set the period to be weekly, and we're just creating additional columns for the animation frames. So now that we have the helper functions done with, this is weekday. So over here, what we want to do is apply. This is the weekday. What was it? Extract weekday, I think it was called. Yes. Extract weekday. So we're just applying the extract weekday function to the entire column. All right. And then we just want to do the same exact thing with sort of all the other periods, right? So else if the period is monthly, then what we want to do is set the animation frame column to, this would just be date or month. You can call it anything as long as you keep consistent and it makes sense to you. Then let's just copy paste this because it's very similar. So this one stays the same. This one stays the same. And instead of extracting the weekday, we just want to extract the date from time. That would be just extract date. Okay. Okay. And lastly, if none of these are applicable, then the animation frame column, then it's daily, so we can call this, we're split by hours. And over here, we're applying extract hours. I think it was called extract hour, singular. Okay. And this right here concludes sort of just creating the additional columns. So now we have all these columns depending on what the period is. All right. So hopefully all of that made sense. Okay, then the last thing we probably have to do for this is just sort everything by time, because we don't want it to be sorted by anything else. We want it to be sorted by time when we are creating our sort of visualizer so that we know what happens when, right? So we can do that in the data frame itself. So data frame earthquakes, and we can just sort the values, sort values by time. This just sorts the data frame by time in case it's not already. And last but not least, we are in a function. So we just want to return the data frame. We can return the center, the starting latitude, and the starting longitude. Okay. So that would be it for the very first, very long function, where we're just fetching all the earthquake data, we're cleaning it up, and we're sort of just getting it ready for the visualizer. Okay, any questions so far? I'll give you all a couple of minutes to catch up if you haven't. Let me actually push all this. And this is part 5. How many changes? 8 insertions. Okay. So we will be using PyPlot to sort of visualize all the data. We imported that earlier over here. So just make sure you pip install PyPlot just so that you don't get any errors when you're trying to run it. So just install all the dependencies and you should be good. Okay, then we got another question. Where's the animation frame column variable defined? So we're just defining it right before we use it, right? So you can probably see them all highlighted right here. We are defining it as the string weekday. And then this is mostly just to make it easier for us to sort of use. I just wanted to copy paste this. So instead of sort of just writing df earthquake quote hours, I just wrote animation frame column so that you know this is the animation frame column name. All right, Jack. You're welcome. Any other questions? Okay, if not, then we can move on to the visualizer. And this is the fun part. This is where you actually get to see things happen. So to start off, this will just have sort of very similar structure to what the last function had. So for this one, we're just going to define the function. Let's see, visualize data, we can call it visualize EQ data. And over here, we obviously have the period, and we can set its default to daily. We have the region, which we can set default to worldwide. And lastly, we have the magnitude threshold, which I forgot what we used last time, min-mag. Okay, so first things first, what we want to do is we want to fetch the earthquake data, right? And then center the latitude and longitude. So this would just be calling the last function is all it is. df earthquake. Actually, let me just copy paste this. It's probably easier. Center latitude and center longitude is fetch earthquake data. Fetch EQ data, and we can just set it to the defaults. Period equals period. Region equals region. And what was the last one? Min mag is min mag. Okay, so this is just calling the function once again. And that should be good for that. Center. Okay, we're just not using those. All right, next we just want to figure out what the animation frame is going to look like based on the period that is selected over here, right? So depending on whatever period is returned, we're going to adjust what the animation frame column is. So if the period is monthly, then we can set the animation frame column And again, if y'all want to use shorter variable names, feel free to. That's probably a better idea. I just want to make this code as clear as possible. For this, we'll be using dates, and then else if the period is weekly, Then we're setting it to just a weekday. And then otherwise, we are setting it to hours. Okay, so this is just naming the columns over here. All right. Next, we want to just create the actual map. So this is sort of the part that matters the most. It's creating the map. I have sort of an outline of what the previous map looked like. Again, if you go to their website, you look at the documentation, you can actually adjust the map to look however you want. You can change the colors, you can change the plotting, you can change a whole bunch of stuff. This is just the default values that I'm using. And again, if you want to check it out, if you want to adjust it, if you want to customize it to your own liking, go for it. That's what you should be doing. All right, so we can just specify the figure as a scatter map box. Map box, I believe that's how you spell it. And then it has a bunch of different parameters. So this is the PX that we're using from here, plotly.express. It just helps you make these graphs very quickly. So very, very useful tool. So over here, the data frame that we're using, data frame is going to be the df.earthquakes or df underscore. So that's sort of the data frame that's going off of. The latitude that we're using is latitude. Longitude that we're using is longitude. The center of the map is going to be at, we need a dictionary of these, so lat equals center lat, and longitude is the center longitude, comma, next we want to figure out what the size, so the size of the sort of circles that we're going to be using, and we can make that dependent on the magnitude actually of the earthquakes. So we can do that. Size equals the magnitude of the earthquake. That should be interesting. The color is based off of the magnitude on the range. So we can set the color to magnitude as well. And then the hover name. So this is the name that shows up when you're hovering over the circle. And we want to set that to the sub area name. Oops, sub area. So again, there's a lot of sort of parameters that are being passed into this map box, but essentially it'll create everything for us. All we need to do is specify how we want it to look and where we want everything to be. All right, our name sub area. We can set the zoom to 1. That's, I think, a default value. The map box style, I have this map box style. Map box style, I've chosen one called Cartopositron. I don't know how to pronounce it, but there are a bunch of other styles that you can also use. So again, I recommend you go onto the Mapbox documentation and check it out. Positron, I believe that's how it's spelled. And then the coloring, we can just leave it as default. Let's use the animation frame. Oops. Frame as the animation frame column. And then we just want to set the title of the of the page as well. So we can set that to title as earthquakes. Or we can be fancier with it and show what the period is and what the minimum magnitude is as well, but we can do that later and just get back to this. Okay, so this right here is sort of what the whole Mapbox looks like. It's just passing a bunch of parameters. If you want to know more about which parameters you can pass in, you can go to their documentation and it'll tell you a bunch about what they have and what you can use. Again, there's almost limitless options, so you can play around with this as you feel like. It doesn't have to be exactly the way it is on my screen. Okay, let me actually check out what's going on in the comments. If we're setting the values of animation frame columns, can we get it from our previous function? Seems redundant. It is redundant, and you definitely can. I just didn't want to return like 5 or 6 different things from a single function. It seems like a lot. So I was just like, okay, we can reduce it a little bit. So again, if you want to, again, that's more of like a preference thing. If you want to add that to your code, you can definitely go for it. Code that I've written just far is, yes, on the GitHub. I am updating it in chunks. Speaking of, let me push this right now. Commit, this would be part 6. And git push. Okay, so the latest changes should be pushed for anybody who wants those. Okay, and then we are basically done. Last, we just need to show what's going on and then return out of this function. All right. And that's it. We are ready to go. So in order to actually see the earthquake data, we need to pass in our own parameters, correct? So for this, we can just visualize earthquake data and we set our own period. Let's try a period of monthly. I think monthly would be cool. Monthly. And do you want to set a region? Let's set region to California. I should set it to worldwide. So we can just leave it as the default, which means we don't need to specify worldwide because that is already implied, but I'm specifying it just so y'all can see. And then the min-mag, the minimum magnitude, let's set that to the 1. So it has to be at least 1 magnitude of 1 for it to show up. All right, let's see if this works. And great, no module named pandas. That's a, do I not have pandas installed? That's always fun. Pandas SPD. Let's try that again. Could be the Python version that I'm using. Let me try 3.9.7. Okay, it's Anaconda 3. Should work with this, hopefully. Just make sure you're on the correct Python version as well. And, oh, it's doing something. There it is, it worked. Okay, so this is what showed up on my screen. Okay, so you can see there's a bunch of earthquakes that's were going on over here. You have a little timeline over here, which you can visualize. Pan, box select, all this stuff. And over here, you can see the magnitude. So this is the range of magnitude starting from 1, which was our minimum, to 5.5, just above 5.5. So you can see that there were a bunch of smaller earthquakes that were going on in California, right? So if actually we decided to change this to just California and then run this, then you can see that it shows these 2 earthquakes that happened in California. If we run it, the timeline, we can see that these are all the different earthquakes that were happening over here during this time period. And then if we just hover over it, we get all the information, right? So we get the date, we get the magnitude, the latitude, longitude, and sort of the location, how far it is from this place over here. And we sort of just stripped it from the higher level location just because we know that this is in the United States, so we don't need to see that. Or if we wanted to look over here, we can see that this we know is in Alaska. So just what city it's closest to, or which landmark. All right, so this is looking pretty good. Any questions so far? Anyone? Is it like not working for anybody? Working just fine? Can't believe it's synced up with all the latest changes. It is not. And again, you can sort of just play around with this, visualize different different periods, visualize different regions, and that will get you everything you need. Okay, any questions? Updating the GitHub, everything should be updated. Let me update it one more time just in case. Commit and part, I believe this is 6. I'll add a question mark in there just because I don't know for sure. And push that. Okay, so it should be most fully updated. URL issue certificate verification failed. That's a strange issue. I don't think I've ever encountered that. If you'd like, we can stay after. I can hop on the Discord and I can help you out with that problem. And someone asked, how do the curly brackets in line 28 work? Line 28. Okay, so these curly brackets are essentially just saying that, okay, anything that goes in these, this is just it's like a quirk of Python where you can have curly brackets and sort of just format this so that whatever's in the curly brackets can't be changed. So you can see that right after that from lines 30 through 35, we're seeing if the period is weekly, then we can update this URL string. Oops. We can update this URL string and format it so that in these curly brackets, it replaces it with the text all week. And the same exact thing for all month and the same thing for all day. Okay. Also having a URL issue, that's interesting. I don't think I have seen that before. Is the format method part of strings? Yes, it is. And Sam asked to install Plotly. Do we just pip install Plotly? Yes, that should work. If you just pip install Plotly, that should get you Plotly. The URL issues, I'm not 100% sure what's up with those. It may be like a security setting on your laptop, so definitely check on that, what it might be. Okay. That is about it. I guess Sky, here's like one more example, right? So if you have this title, for instance, you can write earthquakes, min magnitude. This is just for the title. And then put 2 curly brackets. And then in this, you can just dot format. And then you can just put in the magnitude threshold, right? Min mag. And that should format it so that the minimum magnitude is able to be adjusted into here. And that's just useful for if you have a variable that you want to add to this, but you don't know what the variable might be. So it's like, it's not hard coded in there. Okay. And let's just double check to see if that works perfectly fine. And the answer is yes, it does. So we have earthquakes, min magnitude is 1, because that's what we set it as. And we can see that these are all the earthquakes that happened with a minimum magnitude of 1 in California. And it just shows you their location around other earthquakes. All right. And then again, if you wanted to, you can always just play around with this, right? So you can have another one, visualize earthquake data, period of, and we just set everything empty, and it'll just default to whatever we have set over here. So daily, worldwide, with a minimum magnitude of 1. And we can keep them both. We can run them both, or we can just run one. If you run multiple of this at the same time, it'll just open multiple tabs on your device. So that's not a huge issue. But over here, you can see that the minimum magnitude is 1. This is worldwide. And this is just for today. So you can see it's just August 1st, 2023. And it's just showing you all the earthquakes that happened today. So it's pretty cool because it's fully recent, fully updated, and we're pulling that data. And we're able to see that there were a lot of seismic activity in California, as is normal, but no huge earthquakes. It seems like a 5 over here, 76 kilometers north of Naumac in, I'm not sure which island is this, the Philippines. So in the Philippines, there was a pretty decently sized earthquake. So it's pretty interesting for just visualizing all the data, seeing what's going on, and it's like fully up to date as well. So over here, we have the most recent earthquakes that happened. Okay. All right, questions. Instead of going through the link, we download the file and put it in the folder. That is true. You can download the file. The only downside to doing that would be you wouldn't be able to get the most recent information. So if you want to look at the project 2 weeks from now, then you won't be able to get, if you say, I want today's data, that'll give you the day which you downloaded the information or you downloaded the folder instead of giving you whatever 2 weeks from now, or whenever you pull the data, it won't give you that most recent information. So Sam, that's for yours. Salmaha is saying that they cannot see the result and is giving some error like check proxy settings. Okay, so I think there's just an issue where you're probably not allowed to open up any ports or so on your laptop. So that's more of a settings issue. If you go into your settings and try and just play around, if you want, we can hop onto the Discord after this and try and figure it out. But just play around with the settings on your laptop and we should be able to get it figured out. Yeah, so if you're using Google Colab, it should work on there. I am currently using a Mac OS, so if you're also using a Mac OS, it should work. If you're using Windows, I'm not 100%. I can definitely stay afterwards and look into it. Okay, we have confirmation that it works on Windows. That's great. That's great to hear. All right, I love seeing the chat. People helping everyone else out. But for the code itself, that is about it. I believe I've pushed all the most recent changes, so you should have everything on the GitHub repo if that is what you're looking for. All right, and yeah, I can just hang around and help out anyone else who needs help in the Discord. I will still be here though for a bit, just so that everyone can get their questions answered if they're easier questions. But if you've gotten the project working, if you've gotten up, thank you so much for joining, and just let me know if you have any questions. All right, and I will see you all at the next stream. All right, thank you guys. I will still be here for a bit though, so if you have any questions, feel free to stay on. Other people in the chat can also help out. And if not, thank you so much for joining. Thanks, everyone. Bye. My LinkedIn, just search up my name, Abdullah Hassani. Or you can message me on Discord. Thank you so much. All right, and I guess if you have any other questions, I will be present on the Discord. Okay, I'll just hop on a voice call, or I don't know what exactly they're called. I'll hop on one of those. You can find me on that, and I can answer any questions that you'll have. Okay. And with that said, I will catch you all there if you have any questions. If not, thank you so much for joining once again, and I'll see you all at the next one. All right. Bye, guys.